All right, the last thing we're going to talk about today is converting a mixed radical into an entire radical. So what we're doing is we're doing the reverse process of what we had just practiced. Okay, so before we jump into this question, let's consider what we had just practiced. Okay, so what we had just practiced is we worked with the simplifying radicals, and by simplifying radicals we're writing these, because we're working with the square root, as a product of two numbers where one of those numbers is a perfect square. So I'm going to rewrite this as a product of 100 times 2. I know 25 is a product that works for 200, but I always want to look for the largest perfect square. And my largest perfect square would be 100. I don't want to use 25. All right, so from here, I'm going to now write this as a product of my variables. Well, there's no perfect square for x, so this is going to stay as an x. I'm going to write this as an x squared times a y. Okay, and so now what we want to do is we want to, again, highlight our perfect squares. We're going to bring those outside our radical. So this would be a 10, because the square root of 100 is 10. And the square root of y squared is simply y. And I'm left with 2xy inside my radical. So what we're trying to do today is we're trying to do the reverse. We're starting with this, and we need to work backwards to give us that, and then one step further to give us this. So what we're trying to do is we're trying to take this whole number and put it back inside the radical. So how do we do that? Well, we'd have to square the 10 to give us 100. And we'd have to square the y to give us a y squared, and then we'd multiply all these values to give us this. All right, so let's move on to the question that I gave you originally. So if I wanted to take these whole numbers and put them back inside my radical, in order to do that, in this case I'm working with a cube root. So if I want to take 5 and put it back inside the radical, I do not want to square the 5, because that's what I would do over here if it was a square root, but I would want to cube the 5 because we're working with a cube root. So that's exactly what we're going to do. So we're going to take 5 and we're going to cube that number. We're going to do the same thing with the b squared. If I want to put b squared back inside this radical, I need to cube the b squared, or I need 2 b cubes to put it back inside. So b squared, this is what I'm taking, and I need to cube that value. Just like I cubed the 5, I need to cube the b squared. And then this is going to be still multiplied by what's inside my radical, which is a 3b cubed. Now I want to evaluate or simplify all of this. So 5 cubed would be 125. B squared cubed. So when we take a power to a higher power, we want to multiply these exponents. So this would be b to the 6th times 3b squared. So then finally, one step further, I'm now going to multiply my coefficients, and I'm going to multiply my variable exponents. So my final answer would be 375 b to the power of 8. And that is how you convert a mixed radical into an entire radical.